Hi, did you know people have been making meat for centuries using maths and origami? First, let me tell you about my history. Origami originated in China in 105 AD and was later introduced into Korea and Japan in the 6th century. Origami became very popular in Japan and is now thought of as a Japanese art. Handmade paper was a luxury item only available to the rich, and the paper folding in ancient Japan was strictly for ceremonial purposes, often religious in nature. Origami has since then become popular across the world and is often taught from a young age. The rules for making origami. The paper needs to be square. And no scissors or glue are needed. That's cheating. Let's take this crane for example. If we unfold this to see the original square piece of paper, we can see the folded lines, which we call the crease pattern. You can also see the folded lines cluster around 5 different areas of the paper. The more folds that are in the circle, the narrower the point will be. Here you can see the areas for the head, tail, wings and body. There are even applications for origami in science! When someone has a clot in the vein, doctors can use a scaled-down model of an origami balloon and move it through the vein to the clot. When it reaches the clot, the balloon is inflated and so it widens the vein for better blood flow. Sometimes they remain in the patient forever! And of course it's not made of paper in medical applications, although now I'll show you how to make a paper version. Here we've blown it up with a straw. Scientists regularly use origami to get large objects such as this solar panel into space by folding them down into much smaller sizes and then expanding once in place. We can also use origami to solve mathematical problems like splitting an angle into 3 equal sizes. Here I'll show you how. Also, there are 7 rules that link origami to maths. They are based on the rules of geometry created thousands of years ago. They allow us to understand the different types of folds that we can make. 1. Given 2 lines L1 and L2, you can fold L1 onto L2. Two. Given 2 points P1 and P2, you can fold P1 onto P2. Three. Given 2 points P1 and P2, you can fold a line through both points. 4. Given a point P and a line L, you can fold a line through P, which is at a right angle to L. Five. Given 2 points P1 and P2 and the line L, you can fold P1 onto L so that the fold passes through P2. 6. Given 2 points P1 and P2 and the lines L1 and L2, you can fold a line placing P1 onto L1 and P2 onto L2. 7. Given a point P and the lines L1 and L2, you can fold a line putting P onto L1 so that the fold is at a right angle to L2. These may seem simple, but they are actually really useful when you get to more complicated maths. Thanks for watching!